Okay, we are back, and I want to pick up with problem 11. So let me get this on full screen. There we go. And then let's take a look at the problems from there on, which were more. A lot of times they were more problems than they were proofs, right? They were asking you to use some of the divisibility theorems, and in particular using the big change. This was kind of the dividing line between doing things with the sum theorem, that is sum theorem, and doing things with the product theorem. So let's start with 11a. They say state and prove a test for divisibility. By the way, I love the word divisibility. You see all the I's? D-I-V-I-S-I-B-I-L-I-T-Y. Love it. Just rolling over with I's. But state and prove a test for divisibility by 12. So, okay, no problem. This is going to be based on our product theorem, right? So we just need to point out two things that multiply up to give us 12 that are relatively prime. So I would say something to the effect, note that 3 times 4 is 12, and that 3 and 4, which is 2 squared, that's its prime factorization, are relatively prime. And then you're about done. Then, by our product theorem, and that is a product theorem, for any natural number n like this, 12 will divide the n if and only if 3 divides the n and 4 divides the n. And you're done. That's all there was to that. A lot of people, I think, pass on that problem, maybe kicking themselves now because there really wasn't too much to it. And I'm not actually even going to write out the rest of 11. The big thing was just finding two factors of the numbers that were relatively prime. So, for example, with 14, go with 2 and 7, right? And 15, maybe 3 and 5. And then 18, 3 and 6. No, 3 and 6 won't work. They're not relatively prime. However, 2 and 9 would, right? And for 75, maybe 3 and 25, which we talked about how to spot divisibility by 25 in the last lecture. Okay, so there wasn't a whole lot to 11. Just wanting you to kind of know that you can play that game, okay? All right. The number 25,750 is divisible by 10 and 2. That is true. Spot, you got a 0 in the last digit, so that's divisibility by 10 and divisibility by 2. Is it divisible by 20? Well, I think you can look at it and tell it's not, but let's explain why or why not. Okay, so I would say something to this effect. Note that 10 and 2 are not relatively prime. You look at the greatest common divisor of 10 and 2, it's 2, which is not equal to 1, right? So, our product theorem does not apply to these two numbers. Oh, sorry, to 10 and 2. However, 4 times 5 is 20, and 4, which is 2 squared, and 5, which is a prime itself, are relatively prime. So that number will be divisible by 20 if and only if I can show it's divisible by 4 and 5. 5 actually works, but 4 does not. Note that 4 does not divide 25,730 since, and we've actually got 2 tests on this, you can say 2 times that is 6, or you just look at the last 2 digits, since 4 does not divide 30. Okay, thus, because that one doesn't work, it's an if only if statement, that one doesn't work, then 20 does not divide the 25,730. Okay, that's all they were looking for on that one. Explain why 10 and 2 don't work, why 4 and 5 would work, but 4 is not going to go. Okay? All right. So then I think we got into, well, there's one last one that's maybe a little tough, but it's a pretty good one. I actually in class, had you just identify what it is, and that's what I'll do here too, is we'll do a constructive proof. I'm actually going to build this in they're talking about. It says, show that if K and L are natural numbers that are not relatively prime, then there exists an n such that K divides n, L divides n, but KL does not divide n. Okay, so I'm going to tell you what that n is. I'm going to build it. So here's the way I would do it. Let K be a, what we do is we look at its prime factorization. So P sub 1 has certain power S sub 1 and on, P sub Q, S sub Q. And then there's L, which is P sub 1, and then there's a different power, possibly different, T sub 1, and then with P sub Q, T sub Q. Okay. For primes, P1 dot 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 through PQ, and non-negative integers S1 through SQ and T1 through TQ. All right. Now, I want to refer to 2 different amounts. I'm going to let capital M sub I refer to the max of S sub I and T sub I. So for each prime 1 will have an M1 that is the bigger of the 2. Okay. And then I'll do lowercase m sub I and let that be the minimum of the S sub I and T sub I. Okay, and we're doing this for all I 1 through Q. Okay? And I do want to point out that if I add those 2 things for the same I, there's only 2 things here, right? So even if they're equal, one of them, they're both the max, they're both the min. But there's 2 numbers. So when I add both the max and the min, one of them's one number, one of them's the other number, and I just get S sub I plus T sub I. Again, I going from 1 out to Q. Okay? That becomes important in just a second. So here's my n. Let n be the least common multiple of K and L, which we find by taking the max of these powers of P. P1, M1, dot out here to P sub Q, capital M sub Q. The reason you got to use the max is to make sure it's a multiple, okay, but you don't want anything over the max or it won't be the least multiple, okay? Then We know that I'm going to let, and then I want to get the other part too. I'll let, and I need something other than N. P, Q's already in use. How about Z? Z then, let's let that be the greatest common divisor of K and L. You get that by taking the minimum of each of these powers. So that's P1 to the little m1 all the way out to the P sub Q, little m sub Q. Okay? You do that so that these are, this will divide both of those things, but you take just the minimum, nothing less, because you want to be the greatest number possible that divides both. Okay. Note then that K times L, when we look at this, right, when you multiply, you add their exponents. So this is P sub 1, and you got S sub 1 plus T sub 1, dot, 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 out here to P sub Q, S sub Q plus T sub Q. But now remember, this is the same as the sum of those. So this is P sub 1, capital M sub 1 plus little m sub 1, dot, 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 out here to P sub Q, capital M sub Q plus little m sub Q. Okay? Which means that this is actually the LCM of K and L times the greatest common divisor of K and L. Okay? Note that, now, these are not relatively prime. If they were, this would be 1. Okay? Note that the greatest common divisor of K and L is greater than 1, since K and L have a common prime factor. It's got to be bigger than 1. Okay? So what does that mean? That means that K times L, which is equal to this, is actually greater than the least common multiple of KL, which is my N. Okay? And so I think N does all this, right? It's a multiple of K, it's a multiple of L. Then, let's list it all out. K would divide N. L would have to divide N, because N is a multiple of it. But if N is smaller than KL, there's no way on earth KL can divide it, right? So KL does not divide N, since KL is bigger than N. That's it. N is our number. Boop. Okay? All right. Not hard to show. Not too bad. Okay, it actually goes back, if you go back and look at that previous problem 12, I mean, you could fill in the blanks for all the P sub 1s and all that kind of business. Okay. All right. So now let's take a look at 15A. 15 is where they start getting us now to doing some calculations. Okay. So with 15A, we've got A defined as this digit with a couple D's in it for digits and E. You got to remember, these are single digits. They're limited to 0 through 9. Okay. So if E is equal to 0, find all digits D such that 18 divides A. All right, so that's fine. And 18, you know, we're going to look at, what, 2 and 9, right? Those are the two factors of 18 that are relatively prime. So, okay. Then here's my, I don't know if this is a proof or not, we're solving. But then we know, let's get 0 in here. So then A is equal to 2, 3, D, 4, 7, 0, 4D. Okay? By our product theorem, we know that 18 will divide A if and only if 2 divides A, and then 9 divides A. All right? And there's more to say there, but I'm comfortable with that, since 2 times 9 is 18, and 2 and 9 are relatively prime. Okay. Then D has to come out of this set of numbers. To be even, it's got to come out of 0, 2, 4, 6, and 8. That's it. That's the only way that this number can be divisible by 2. Is that last digit has to come out of this. There's no K floating around, so let me let K be the sum of the digits. So this is 2 plus 3 plus D plus 4 plus 7 plus 0 plus 4 plus D, which, okay, 5, 9, 16, 20. Yep, that's what I got. 20 plus, and then I got 2 D's. Okay. Period. 9 will divide A if and only if 9 divides this sum of the digits K. Okay. And so you can just run the cases. If D is 0, then K is 20. Doesn't happen. Not divisible by 9. If D is 2, then this is 20 plus 4, or 24. Doesn't work. If D equals 4, K here is 20 plus 8, 28, doesn't work. If D is 6, we've got K is 20 plus 12, that's 32, doesn't work. If D is 8, K is 20 plus 16, which is 36, and 9 divides 36. So our only solution is D equals 8. Okay. All right. 15b says, okay, let E be 1. And show that nothing works. All right. Well, similar setup, right? We put that E equals 1 in there, so A is 2, 3, D, 4, 7, 1, 4, D. Our product theorem um, 18 divides A if and only if 2 divides A and 9 divides A, because 2 times 9 is 18 and they are relatively prime. Okay. Then, okay, to be divisible by 2, has to come out of this, has to come out of this set of numbers, 0, 2, 4, 6, 8. Okay. Let's let K be the sum of these things. So 2 plus 3 plus D plus 4 plus 7 plus 1 plus 4 plus D. This better be 21. 5, 9, 16, 17, 21, right? 21 plus 2D. Okay. So you got 5 cases, just check them. If D is 0, then K is 21, and that's not going to work. It has to be divisible by 9. If D is 2, then this is 21 plus 4 equals 25. Nope. If D is 4, this is 21 plus 8, which is 29. Nope. If D equals 6, this is K equals to 21 plus 12, which is 33. Nope. And if D is 8, K is 21 plus 16, 37. Nope. Thus, 18 does not divide A for any value D. Okay? Not too bad. The only one where it might get a little messy is when they say, okay, forget about E being something. Just tell me all the possible answers. Okay? So you got E and D in there. We're not going to set E to anything. But we will set about proving stuff. We'll say, okay, by our product theorem, uh, 18 will divide A if and only if 2 divides A and 9 divides A. You can go ahead and say, if you want to, since 2 times 9 is 18 and 2 and 9 are relatively prime. Okay, or not. I'm going to add it. Then, to be divisible by 2, we know that the last digit D has to come out of this set, 0, 2, 4, 6, and 8. Okay. Let K, let's add them up again. So this is 2 plus 3 plus D plus 4 plus 7 plus E plus 4 plus D. So let's see, 5, 9, 16, 20 plus E plus 2D. Okay. 9 will divide A if and only if 9 divides K. So, if D equals 0, then what's K? K is 20 plus E, right? And I need something here that's divisible by 9. 27 would work. Okay, but I can't go, I've got to use 0 through 9, so I can't go down from 20 to get 18, so the only thing that I can get to is 27. So E equals 7 gives K equal to 27, and we have the point 0, and then E is 7. Okay, that's one of our answers. If D is 2, then K is 20 plus E plus 4 equals 24 plus E. Again, I can get to 27, but that's about it. So if I add 3 to that, so E equals 3, gives k equals 27. So it looks like I've got 2, 3. There's another one. If D equals 4, then K is 20 plus E plus 8. So 28 plus E. Well, 27 is out of range again, but I can get it up to 36 by adding an 8. So I have 4 and 8. Okay. If D is equal to 6, then K is 20 plus E plus 12, which is 32 plus E. So I can definitely get us up to 36, but that's about it. That's it. So E equals 4 gives K equals 36. So I get the point 6, 4. Okay? And then lastly, if D is 8, then K is 20 plus E plus 16, which is 36 plus E. So E can be 0 on this one. Or it can be 9, and E equals 9 gives K equal to 45. So I've actually got 2 points with D equal 8. I've got 8, 0, and 8, 9. Okay, and I think that's everything. We've run the. That's a proof by exhaustion, right? We're now exhausted. Okay. 16 we did A and B, and I will do those and then save the next one till later, till we do it in class. Let B be the number represented by 1E765E4 to F. A natural number. Show that if F is 0, then 22 does not divide B for any E. Okay. So let's get F equals 0 in there. And B is 1E765E4 to 0. Okay? Alright, so 22, two factors of 22 that are relatively prime would be 2 and 11. Okay? We'll say that by our product theorem. Sorry. Okay. By our product theorem, not 18, sorry, I'm still on the last problem. 22 divides A if and only if 2 divide B, still stuck in that last problem, if 2 divides B and if 11 divides B. Okay. We have 2 divides B, okay, since the last digit is 0. So what we do for the divisibility test by 11 is we take certain ones, the positions where it's 10 to an even power, and we add those digits, and the odd powers we subtract. So I'll let K be, and so you got 0, let's do the adding. So you got 0 plus 4 plus 5 plus 7 plus 1, and then we'll subtract 2 plus e plus 6 plus e quantity. So what is this? This is 9, 16, 17 minus, and this is 8 plus 2e. So this is 9 minus 2e. Okay? 11 will divide b if and only if 11 divides k. That's the divisibility theorem, or the divisibility test for 11. 4, and this, I'm going to give this line to Matthew Riggle, who pointed this out. For e that's ranging between 0 and 9, okay, we have, okay, the smallest this could be is if e is 9, and so this is 9 minus 18, negative 9. And then the largest it could be is if this is 0, so it's 9. So the only possible k divisible by 11 is 0. But that's a problem, because then if you look at 9 minus, 9 minus 2e equals 0 has no integer solution. Has a solution, it's just e is going to be a fraction, right? Thus, 22 does not divide b. Okay. All right, one more problem, and we will cash this one in. If f is equal to 2, then find all e that make that work. And they seem to imply that this time we'll be able to find some. Okay. So let's get that 2 in there. One e 7 6 5 e 4 2 2. Okay. Is that right? 2 is the first one. 0. Okay, that's fine. Okay. Then by our product rule, (22) divides b if and only if 2 divides b and 9 divides b. Since 2 times 9 is 18, I am still stuck on that last problem. Sorry, 11. Excuse me. 2 times 11 is 22, and 2 and 11 are relatively prime. I don't know why I'm still trying to work that other problem in my head. Sorry. We already have that 2 divides b, since the last digit is a 2. Let's look at that bunch of things we add up, and then minus the bunch of other things we add up. Okay, so let k be, alright, we'll add the 2 plus the 4 plus the 5 plus the 7 plus the 1. Okay, minus, and now 2 plus e plus 6 plus e. So we'll get here 6 and 5 is 11, 18, 19. Minus, and then I've got 8 plus 2e. So this is 11 minus 2e. Okay? And again, I'll kind of take Matthew's approach on this one. E goes between 0 and 9. The smallest K could be is if E is 9. 11 minus 18 would be a negative 7. And the biggest K could be is if that's a 0 to be 11. Okay? So both K equal to 0 and K equal to 11 are possible. Now the question is, can we find an E that makes that happen? If K equals 11 minus 2E equals 0, then there is no integer E solves the equation. If K, 11 minus 2E equals 11, then you pull this over, pull that over, E has to be 0. And so the only solution that we found. And that's it. Okay? Now, 16C, which we didn't get to in class because we ran out of time, as you go through now and say, okay, forget about restrictions on F. Give me pairs E and F that satisfy this. But I think you've got the template that you need to get that done. All right. I will hush now and let you get on with your problems. I hope this is helping, and I will talk to you tomorrow.